Injectors are also solenoid type components which are in charge of delivering the right amount of fuel to the engine. Injectors are for the most part negatively controlled. This means that actually one side of the injector is going to be connected directly to the voltage supply line, while the other side is going to be pulse triggered in order to achieve the actual fuel flow. In this case, the computer actually pulsates the injector by the actual ECM microprocessor applying a very small pulse to the transistor driver circuit. This small pulse will actually cause the transistor to become conductive. Every time a pulse is actually applied to the transistor base lead, the driver or transistor would close, completing the circuit from negative through the injector coil to positive. By the ECM microprocessor applying a specific pulse to the transistor or driver base lead, a specific fuel delivery rate can be achieved. In this case, we actually see how the actual pulse applied to the base of the injector causes a current to flow through the transistor, through the injector coil winding, and up the actual voltage supply source line. Anytime the actual microprocessor applies a pulse to the base lead, the injector pulsates and a specific amount of fuel is injected into the engine. The length of the pulse being applied to the injector base lead is the one that is going to determine the injector open time. Most injectors are directly tied to the voltage source through the ignition switch, but in this case we actually see a diagram corresponding to a Chrysler ASD or automatic shutdown relay. The ASD or automatic shutdown relay provides the actual voltage source to the actual injector. The other side of the injector is always going to be negatively triggered or pulsed by the ECM. The ASD relay is activated anytime the actual ECM sees a crank sensor input. In other words, the ECM has to detect that the engine is actually turning for the ASD relay to be activated. In this particular case, we actually see in light blue the actual current path that actually energizes the injector to open. This current path again flows from the negative side of the ECM through the internal transistor, through the injector winding, and up through the relay and the voltage supply line. Here we can see in purple the actual current path of the actual activation of the ASD relay. And again, this relay, clearly you can see that it is negatively controlled by the ECM, since one side of the relay coil is directly connected to the voltage supply source. So current flows from the negative side of the ECM circuit through the internal ECM driver circuit, which turns the relay on, through the actual relay coil and up the voltage supply line. In here we can actually see both current paths corresponding to the ASD relay activation circuitry. The light blue current path corresponds to the actual injector activation circuitry, and the purple current path corresponds to the actual ASD relay activation circuitry. Again, voltage, regardless of which current path we're actually talking about, flows from negative to positive.